times. Okay, good morning class. So at this point we're looking at probability. We have just marked the exercise 2. So now we're looking at the examples for exercise 3 on page 315. The examples on page 313. So now we're going to look at arrangements of objects in a row. Okay. So as you can see, the Quran continues here. So we are told in example 10. In how many ways can 3 girls and 2 boys sit in a row? Okay, so how many boys are there in total? 3 boys and 2 girls. Okay, so in A. So there's no condition given. So the girls can be first, the boys can be first, the girls can, whatever. The girl, boy, 2 girls, first a boy and 2 girls, and then 2 boys, or 2 boys, 2 girls, a boy, and the combination is not endless, but can be calculated, but there's quite a bit of combinations. So what I do is I draw again bits. So it's 1. How many placings are there? 5. So it's 1, 2, 3, 4, 5. So how many options do I have for the first play, for the first seat? 5. Then, if one person is sitting, yes, 4. Then 3. Then 2. Then 1, which is the same as 5 factorial, which is 120. Okay, let's look at B. In how many ways can they sit in a row if a boy and his girlfriend must sit together? Okay, that's also haram, no? So, how many seats are there? How many bits should I draw? Okay, let's take a scope here. So I'm going to draw. How many seats are there? 5. So why you want to draw 2 seats? It's 5. Okay. So if the girl and a boyfriend needs to sit together, so it could be like this: the girl and the boy. Okay. Or it could be, so if this is the case, okay, then I got 3 factorial here. Can you see? Because then I got 3 options, 2 options, and 1 option. Not so. But this could be in 2 ways as well. Can you see that? So that's 2 factorial times 3 factorial. Because the girl can sit first, or the boy could sit first, and the other one is sitting second. Wherever it is. No? So that is 1 way. Otherwise, it's 1, 2, 3, 4, 5. If the girl and the boyfriend, the girlfriend and the boyfriend is sitting there together. Okay? Then we have, how many options do I have for this placing? How can you get 5? The girl and the boy sitting together, so let's sort them out first. The girl, boy. So how many combinations are here? 2 factorial. Not so. Then how many options do I have in the first bit then? 3. Then 2. Then so it's times 3 factorial. Can you see that? Now, if the girl and the girlfriend and the boyfriend sits in those 2 seats, then how many, then my calculation for that is going to be 2 factorial, because the girl can sit first or the boy can sit first. That's why I got 2 factorial. No? So how many options do I have for this bit? 3. Then 2. Then 1, which is 3 factorial times 2 factorial. Okay. We go one step further. Okay. So, if the girlfriend and the boyfriend is sitting there together, okay, so this should be 2 factorial. How many options do I have here? 3 then, so it's times 3 factorial. Not so. So the total here is simply going to give you 2 factorial times 3 factorial. And how many of those are there? 2 factorial times 3 factorials. Okay, sorry about this. Let's just check if everything's in order. Well, this was the examples we did. Okay, so they get out. Sorry about this. So it's going to be the total of 2 factorial times 3 factorial. And how many of those combinations are there? It's 1, 2, 3, 4. Can you see that, people? There are 4 of those combinations. So in other words, I must multiply this by 4, or I'm going to say 2 factorial times 3 factorial plus 2 factorial times 3 factorial plus 2 factorial times 3 factorial plus 2 factorial times 3 factorial. Okay? Which now gives us 2 factorial. So 2 factorial. 2 factorial times 3 factorial. Since there are 4 of those, so to give you an answer of 48. Now it's not going to make sense to go through this notion all the time, okay, because it's quite a bit of writing down to do. Not so. Imagine there was now 7 seats. Then it's going to become even more complex, okay, and more tedious. Right? So what we do is we say, okay, let's look at another way of calculating the same thing. So let's go. We got B. In how many ways can they sit in a row? A boy and his girlfriend must sit together. 1, 2, 3, 4, 5 bits. So what we do is, we then say the girlfriend and the boyfriend is sitting together, we bind them. Okay, so how many ways can they sit together? 2 ways, so it's 2 factorial. Not so. Then they now become as 1 bit on the counting line. Okay? So how many bits do we then have? 1, 2, 3, 4. And I multiply that by 4 factorial. Okay? So it's 2 factorial times 4 factorial. Let's again here. 2 factorial times 4 factorial. That is simply 48. You guys understand? So you don't have to go through all that drawing of bits all the time. We just consider when there's a bind or where a condition has to be together, then we put them together and we bind it. Then it becomes 1 bit on the counter. Okay? So that's simply going to give you an answer of 48. Okay, so let's look at C and D. Okay? So in question C, we are asked, in how many ways can they sit in a row if the boys and girls are each to sit together? So how many bids do we draw then? 5. So it's 1, 2, 3, 4, 5. So if all the boys are to sit together, then how many bids should we bind? 3 bids. Because there's going to be boy, boy, boy. Not so. So they can sit in how many ways? How many options do I have for the first bid of the binded bids here? 3. There? 2. There? 1. So in other words, if I bind them, how many options do I have? 3 factorial, yes. Okay. Then this needs to be girl, girl. Are they binded? Yes, they have to sit together. How many ways can they sit? 2 factorial ways. Not so. Did they say the boys must be first and then the girls? No. So it could have been girl, girl, boy, boy, boy. Not so? Instead of having as I have it here, boy, 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 girl, girl. So in other words, that can be arranged how many ways? 2 factorial ways. Okay. So it's going to be 3 factorial times 2 factorial times 2 factorial. Give you an answer of 20. Okay. Let's look at D. In D we are told, in how many ways can they sit in a row if just the girls are to sit together? How many bids would I draw here? 5. Because there's 5 seats. It will remain 5. So it's 5 seats. So if the girls are to sit together, what do I do is I bind them. So how many ways can the girls sit together? 2 factorial. Then this now becomes how many bids? 1 bid. Can you see that? So we count 1, 2, 3, 4. So I multiply it by 4 factorial. So it becomes 2 factorial times 4 factorial should give you the same answer as B. Which is 48. Okay. So let's look at E and F. In E we are told in how many ways can they sit in a row if just the boys are to sit together. How many bids do I draw here? 5. 1, 2, 3, 4, 5. So the boys are to sit together, I write B, 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 and then I bind them. They must be together. So how many ways can the boys sit all together? 3 factorial ways. So it's 3 factorial times, this now becomes 1 bid, not so? So it's 1, 2, 3. So it's times 3 factorial. So 6 times 6, which is 36. Okay, let's check. 3 factorial times 3 factorial. 36. Okay. In F, in how many ways can they sit in a row if the boys and girls are to alternate? What does it mean to alternate? Change. So it's going to be 1 boy, 1 girl, 1 boy, 1 girl, 1 boy, 1, and so on. Not so. Even if we look at this scenario, there are 3 boys. So if I start with a girl, boy, girl, boy, So does this fit on the criteria they're looking at? No. So in other words, we have to start off with a boy. The scenario is as follows. Okay? We start off with a boy, girl, boy, girl, boy. Okay. So how many options do I have? Let's count the boys first. How many options do I have for this bid? 3. Any one of the 3 boys can sit. So it's 3, 2, 1. So it's 3 factorial. Not so. How many options do I have for this this seat? 2. So it's 2 and 1. So it's 2 factorial. Can girl sit first? No. So that's the only combinations here. So it's 3 factorial times 2 factorial, which gives you 12. 3 factorial times 2 factorial is 12. Okay. So any confusion there? So with that you should be able to answer exercise 3. Alright.